Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day.
Here we go. Good morning sa lahat ng mga tagapakinig natin sa ating 106.3 FM at sa lahat ng mga viewers natin sa ating Facebook Live. Welcome back to our scientific time for Science 9. So ngayong araw, makakasama natin sa ating live discussion ang mga magagaling na Science 9 teachers. Isa na dito si Sir Ronnie Abalos, Ma'am Donabel Velasco, Ma'am Jennifer Lacambra, at syempre kasama natin sa ating technical side, Ma'am Riza Marsan and Ma'am Riza Marsan, Sir Dennis Mendoza, and Sir Mark. So we are now on our first week sa ating 3-week series ng ating scientific time for Science 9. So I guess ang ating mga grade 9 learners ay ready na para makinig sa ating RBI lesson for this week. So may we now listen to the RBI lesson prepared for this week. We will be back.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, sana magtulong-tulong, sulong edukalidad, Dance Radio. Learning is amazing.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science. This is your class, and this is Science. And now, here is your host for the day.
Good day, our dear listeners, especially our dear new normal learners from grade 9. This is your school on the air in science. We are glad because you are here with us in our alternative delivery mode of education through this radio-based instruction. It is a great privilege that you can join us in fun learning through radio. I am Teacher Prince Bugawisan, your host and technical specialist for today's episode. You are listening to the School on the Air, the WDR 106.3 Dance Radio, where learning is amazing. I know you are excited as I am, so get ready, grade 9 learners. Make sure that you are in an area where you feel comfortable and far from noise or any disturbance so you can listen well to this broadcast. At this moment, please get your learning activity sheets for Science 9 titled Uniformly Accelerated Motion, Horizontal Motion, and Vertical Motion. Always remember to take down important concepts that you hear today. I hope you are all set and ready to listen and learn from our lesson on uniformly accelerated motion. This time, I turn you over to our radio teacher in science, Teacher Benjelu Paraiso.
Wonderful day, our dear grade 9 learners. I am Teacher Benjelu, your radio teacher in science. And I am with you until we finish our lesson on uniformly accelerated motion. After this episode, you should be able to describe how a free-falling object moves in terms of its displacement in a given time, its velocity, and its acceleration. When you were in grade 7, you learned about the different terms we can use to describe an object's motion, right? You also learned to make graphs to represent an object's motion. Can you still recall them?
Yes, ma'am.
That's good! Now, would you differentiate the terms distance with displacement?
Ma'am, distance is the measure of how far the location of an object is from its initial location, while displacement tells how far these locations are with direction. For example, when I move 5 meters to the right, the distance I traverse is 5 meters while my displacement is 5 meters to the right.
You are right! How about speed and velocity? Would you differentiate these terms?
Ma'am, speed is the measure of how fast an object moves, while velocity is the quantity that describes both how fast an object moves and the direction of its motion. Like in the forecast of typhoons. Suppose the forecaster says the typhoon is moving slowly with a speed of 10 kilometers per hour northwest. In that case, the speed of the typhoon is 10 kilometers per hour while its velocity is 10 kilometers per hour northwest. Velocity is a vector quantity that is expressed with magnitude and direction while speed is a scalar quantity.
Very good, my dear learners! Another term you have learned is acceleration. Would you define acceleration?
The term acceleration is defined as the rate of change in velocity expressed with the distance over the unit of time squared, ma'am. The faster an object picks up speed, the higher is its acceleration.
Very well said! In this episode, we will be analyzing the graphs of motion of a free-falling object, and it is essential that we review the different graphs of motion and their meaning. Let's start recalling the position versus time graph. What information about the motion of an object can we get from its position versus time graph?
The position versus time graph tells us where the object is at a given time and the direction of its motion relative to its original position. The gradient or the slope of the position versus time graph tells us the speed of the object. The steeper the graph, the faster the object moves. The shape of the graph tells us something about the motion of an object. A horizontal graph means that the object is not moving. A slanting graph means the object is moving with a constant speed, and a curved graph probably means that the object is accelerating, ma'am.
Thank you for comprehensively recalling the position versus time graph. How about the speed versus time graph? What information can we get by looking at the speed versus time graph?
Ma'am, the speed versus time graph tells us much information about how an object moves. This graph can tell us the instantaneous speed of an object at a given time. The slope of the speed versus time graph is the acceleration of the object. If the slope is 0, or when the graph is horizontal found at the x-axis, we can say that the object is not moving. If the graph is found above or below the x-axis, we can say that the object is moving with a constant speed. The movement is to the right if the graph is above the x-axis, and the movement is to the left if the graph is found below the x-axis. The faster the object gains speed, the steeper the speed versus time graph becomes. The area below the speed versus time graph tells us the distance traversed by the object.
Amazing! You have learned a lot when you were in grade 7. I can now say that you are ready for our lesson, which is about the motion of free-falling bodies. We will be analyzing the motion of a free-falling bodies after this infomercial.
Facts about COVID-19. What is COVID-19? COVID-19 is a disease caused by a new strain of coronavirus. What are symptoms of COVID-19? Symptoms can include fever, cough, and shortness of breath. In more severe cases, infection can cause pneumonia or breathing difficulties. How can we prevent COVID-19? To prevent the spread of COVID-19, clean your hand often. Maintain a safe distance. Wear masks when physical distancing is not possible. Don't touch your eyes, nose, or mouth. Cover your nose and mouth with your bent elbow or a tissue when you cough or sneeze. Stay home when you feel unwell, and if you have a fever, cough, and difficulty breathing, seek medical attention.
This health advisory is brought to you by World Health Organization, Doña Aurora National High School, and this station.
I'm back! Let us now discuss the motion of a free-falling object. During this lesson, we have to consider the following assumptions. First, that the object is moving in a straight line. Second, that the object is moving with constant acceleration. Third, that there is no air friction. Fourth, that the object is thrown vertically upward from the ground and ends up to the ground where it is initially is. And fifth, the object is moving close to the surface of the earth at sea level position. Let's start by finding a soft object and throw it vertically upward. Just a reminder, my dear learners, make sure that you do not throw an object hard enough that you may break anything or hurt someone close to you. Make sure that you do not throw an object hard enough that you may break anything or hurt someone close to you. As you throw the object up in the air, I want you to observe how fast it moves and how long it stays in the air before falling back to you. Are you ready? You have 10 seconds to do the activity.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm back! I hope nothing was damaged or no one was hurt during the activity. The activity might be that simple, but we can learn a lot from this. I already made the position graphs of the object thrown vertically upward for your analysis, my dear students. Let's start analyzing the position versus time graph of the object. The position versus time graph is a curve, which is a parabola that opens downward. Would you tell the information that you get by looking at the position versus time graph, dear learners?
Ma'am, since the graph is parabolic, it means that it is accelerating while it hangs in the air. It slows down as it moves upward, momentarily stops at the highest position, then begins to speed up as it goes down.
Very good observation, dear learners. What can you say about the time spent by the object in moving up to the highest position and the time spent moving down back to the ground from the highest position?
The graph shows that the time spent by the object moving upward is the same as the time spent moving down, ma'am. It means that the highest position was reached at half of the time it spent in the air.
Yes, you're right. What can you say about the initial position and the final position of the object?
Ma'am, the initial position is the same as the final position.
Very good. We now proceed to the analysis of the object's speed versus time graph. The speed versus time graph is a line that slants to the left and runs over the first quadrant, across the x-axis, and then over the fourth quadrant of the speed-time plane. What information can we get about the motion of the object thrown vertically upward by looking at its speed versus time graph?
Ma'am, the following information can be extracted from the graph. 1. The object is moving with a constant acceleration while it is in the air. Since the graph is slanting to the left, the acceleration is negative. It has a value close to -10 or close the acceleration due to the Earth's gravity at sea level. 2. While the object is moving upward, it is slowing down and it speeds up as it moves downward. 3. At one point before it moves down, the speed becomes 0. However, the object is still accelerating. And 4, there is symmetry in the upward and downward motion of the object in terms of time, speed, and distance.
Amazing, my dear students! Now, I want you to compare the distance versus time graph and the speed versus time graph. Would you tell me where the object is when the speed is 0?
I can see that the moment when the speed is 0 is the same moment when the object is at its highest position, ma'am.
You're right! Thank you for sharing your accurate observations about the motion of an object thrown vertically upward, my dear students. Let us now apply what you have learned today by answering the questions following this scenario. A pitcher in a baseball game throws the ball vertically upward with a mild speed of 30 meters per second. If it takes 3 seconds for the ball to reach the highest position, how long will the ball stay in the air?
Ma'am, since there is symmetry in the upward and downward motion of the ball, it will stay in the air for 6 seconds.
Correct! At the highest position, what is the speed of the ball?
Referring to the speed versus time graph, ma'am, the ball momentarily stops at the highest position.
Yes, that's right. If it momentarily stops at the highest position, what is its acceleration at that point?
Although it stops at the highest position, it is still accelerating, ma'am, since gravity is pulling it down. The acceleration is close to -10 meter per second square or equal to the acceleration due to gravity of the Earth.
You're on point, my dear student. Next, if it was thrown upward with 30 meters per second speed, how fast will it hit the hand of the pitcher when it goes down?
Ma'am, recalling that there is symmetry in the motion of the ball in terms of speed, the ball will hit the hand of the pitcher with 30 meters per second speed, but this time the ball is moving downward.
Excellent! You have done well in analyzing the motion of an object thrown vertically upward by looking at its motion graphs, my dear students. Would you summarize the things you have learned about the motion of an object that is thrown vertically upwards?
Ma'am, in this lesson, I learned the following about the motion of an object that is thrown vertically upward. First, the object is accelerating and its acceleration is the acceleration due to gravity or 10 meter per second square. Second, the object is slowing down as it moves upward, momentarily stops at the highest position, and gains speed as it goes down. And third, there is symmetry in the upward and downward motion of the object in terms of time, displacement, and speed.
Very well said. Thank you for that brief but accurate and informative summary. If you have queries about our lesson, do not hesitate to contact your subject teachers in Science 9. You may contact them through Facebook messengers or through their contact numbers written at your modules. You may also comment your questions by participating in the live discussion through Facebook Live just after this RBI lesson. The next lesson, which is about projectile motion, will be discussed later in the live discussion. Please keep the notes you have taken in this episode open to help you understand that lesson. Thank you for staying with us up to the end of this RBI lesson. We now go back to our host, Teacher Prince Bugawisan.
Thank you very much, Teacher Benjelu, and also to our dear learners for spending another wonderful day with us. I hope your learnings today made your time listening to the radio worthwhile. I would like to acknowledge the teachers behind this School on the Air lesson. Teacher Benjelu Paraiso, your radio teacher on the air. Teacher Shirley Acosta and Teacher Annabel Rodriguez, the editors. And I am Teacher Prince Bugawisan, the scriptwriter, the technical specialist, and your radio host. Keep safe and always observe quarantine health protocols for everyone's safety. Goodbye!
Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science.
Dance Radio, siniparalan sa radyo, atid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta't magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
And we're back. Ayan. So, mga grade 9 learners, napakinggan na natin ang ating RBI lesson for this week. So, let us flash our Ma'am Riza, ating PowerPoint. Ayan. Ma'am Annabel.
Kalimutan mo yung pangalan mo.
Ayan. So, before we move to our topic for this day, let us first review kung ano yung mga napag-aralan nila nung sila ay nasa grade 8 na kailangan na concept sa ating topic for today. Di ba, ma'am?
Yes.
Isa dito ay yung Newton's second law of motion. This is the law of acceleration. Okay. Ano yung sinasabi sa law of acceleration? Yan, the force, it is summarized in this equation. Force is equal to mass multiplied by the acceleration. So, tignan nga natin, ma'am, kung nare-recall pa nila yung law of acceleration, ating mga grade 9 learners. Ayan. So, let us try to complete this paragraph. Ayan.
Siguro, Ma'am Jen, pwede natin sagutin yung unang blank sa una. But maybe also request our learners to try answering to try to key in your answers here. May mga choices naman tayo in this paragraph. Like for example yan, yung mga choices natin, nandun siya sa loob ng mga parentheses natin. And our learners could actually answer.
Yes, ma'am. Check muna natin, ma'am, kung nakikinig na talaga sila, no? So, hello sa ating mga live viewers, sa FB live viewers natin, and sa mga nakikinig din sa radyo. Okay. So, dito sa ating comment box, pwede nyong i-comment yung inyong sagot sa ating completion ng paragraph, di ba, ma'am? Ayan. So, pwede nyo kaming sabayan, mga anak, no? Hello, hello. Yan. So, the law of blank. So, ano yun, ma'am?
Siyempre, so second law of acceleration, Ma'am Jen.
Yes, the law of acceleration. So, the acceleration of an object as produced by a net force is it directly or inversely proportional to the magnitude of the net force? Then is it the same or opposite direction as the net force? And is it directly or inversely proportional to the mass or weight of the object? So, ayan, apat bali yung sasagutan natin dyan, ma'am, ano?
Yes.
Na mga keywords sa law of acceleration. So, tignan nga natin kung anong sagot.
Ma'am Riza?
Ayun. So, nakikita natin dyan, the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force. Anong ibig sabihin yan, Ma'am Annabel? 'Di ba? Yung as the net force increases, the acceleration also increases. So, mas mataas yung net force na in-apply, meaning the greater will be its acceleration. And, dun tayo sa kanyang direction. So, in the same direction as the net force. Ang tinutukoy dyan is yung acceleration. So, yung acceleration ng applied force is the same dun sa direction ng acceleration. Hindi siya mag-opposite. Ano? Kung saan mo banda siya tinulak, halimbawa forward, meaning forward din yung kanyang acceleration. And inversely proportional to the mass. It's the mass, hindi weight, no, of the object. Meaning, the greater the mass, the lower its acceleration. So, mas mababa, mas magaan, mas mabilis yung kanyang acceleration. So, yun yung sinasabi sa second law of acceleration.
Second law of motion.
Second law of motion, the law of acceleration, yes. Newton's law yan, ano, ma'am?
May mga sumagot ba?
May mga sumagot.
Si Christian daw, Ma'am Jen.
Oo, Christian Vino. Thank you for answering, anak. Anong sagot niya, ma'am? Hindi ko nakita.
Christian Vino is from 9 Darwin.
Oo, yan. Very good, ano? Mga nagpa-participate ang ating mga estudyante. Yan. Next slide, ma'am.
Okay, ano naman to, Ma'am Jen?
Okay, so on the screen, we can see a red car na dinadrive ng isang lalaki, no? So, sabi dyan, the larger the force applied on an object, the larger its acceleration. Yan. So,
nabanggit na yan actually kanina.
Oo, nabanggit na natin yan kanina. So, tignan lang natin yung application niya dito. So, yung force kasi ng car is nakadepende sa kanyang engine, di ba, ma'am? So, the car here na using its engine, so yun yung magpapa-accelerate sa kanya. Pero kapag yung engine ng car ay gagamitin mo sa mas malaki, halimbawa truck, anong mangyayari dun sa kanyang acceleration? So, syempre, mas maliit yung kanyang engine, medyo mahihirapang mag-accelerate yung truck. So, kailangan ng truck is mas malaking engine to exert more force on the object. Kasi yung mass niya, 'di ba, ma'am, mas malaki yung kanyang mass. In comparison naman, halimbawa, yung tricycle, isang tricycle ay fully loaded siya, no? Meron siyang 5 pasahero. Tapos yung isa naman, isa lang. So alin dun, ma'am, yung mas mabilis mag-accelerate?
Siyempre, yung mas kukonti ang laman.
Yes. Yung mas kukonti ang laman, ma'am. Kasi yung kanyang mass is mas mababa kumpara doon sa 5-passenger na tricycle. Okay. So yun yung sinasabi sa ating second law of motion. So eto, ma'am, di ba nakasakay na tayo sa car o sa mga jeep? Minsan, lagi ba siya na, ma'am, na dire-diretso lang, ganyan?
Actually, hindi pare-pareho yung kanyang bilis. So, may mga pagkakataon na mabagal, may mga pagkakataon, ma'am, na syempre umaarangkada, and sometimes it even stops.
Yes. Doon sa mga moment na tuloy-tuloy lang siyang umaarangkada, and nagbabago yung kanyang velocity at a constant rate, so we call that a uniformly accelerated motion. Ma'am Riza?
Ma'am Riza?
Oo. So, ano pa ba, ma'am, yung mga example pa ng isang uniformly accelerated motion?
So makikita natin, Ma'am Jen, yung mga susunod nating pictures na nagpapakita ng uniformly accelerated motion. Siguro ipapadescribe natin kay Ma'am Donna or kay Sir Ronnie. Mamaya itong mga to, Ma'am Risa, tingnan nga natin yung mga susunod na pictures natin that shows uniformly accelerated motion. Bakit uniform yung acceleration nila? Ma'am, yan.
O yan, ang mga masasabi nyo dyan, ma'am, sir.
Motion of a bungee jumper, motion of skydivers. Bagay ni Sir Ronnie yung una. Masakit sa akin.
Gusto ko matry yan.
Sige.
Yung pangalawa, gusto ko matry.
Mukhang wala akong planong subukan. Baka maputol yung tali.
Okay.
Okay,
So,
di ba,
sige.
sige. Paano naging uniformly accelerated motion yan, Sir Ronnie? Di ba bumibilis siya?
Bumibilis habang pababa ng pababa.
So, ganun din yung pangalawang natin dito, picture natin, yung sa skydiving.
Yes.
So, parang pag nasa taas ka, hindi gumagalaw,
Yes,
Yes,
pero
pag pinapanood sila, ma'am, parang hindi sila gumagalaw. Pero yung totoo ay bumibilis sila pababa.
Habang pababa.
Yes. May diagram dyan, Ma'am Riza. Ayan. So, yung kanina, ma'am, na yung bungee jumper and skydiver ay experiencing free fall. So, makikita natin dito na doon sa kanyang initial point or after 1 second ay nadagdagan siya ng 9.8 meter per second downward. So, meaning nag-accelerate siya by 9.8 meter per second square, no? Ano ba yung 9.8 meter per second square, ma'am?
That's the acceleration due to gravity.
Yes. So, yung
mali pa yung masabi ko.
sa mga free fall ay ito ay nakaka-experience ng acceleration due to the gravitational force of the earth, ano? So that is dito sa earth ay meron tayong 9.8 meter per second square na acceleration. Constant 'yan, 'di ba? Okay, then yung second point niya naman after the second, so meron siyang 19.6 meter per second. So ganun pa rin, nadagdagan siya ng 9.8 meter per second na velocity. Okay, so ganyan ang na-experience ng mga nakaka-experience ng free fall. So ano pa ba, ma'am, maliban sa kanina yung sa vehicle na constantly accelerating, sa mga nasa free fall, ano pa ba ang ibang example ng uniformly accelerated motion natin?
Actually, ma'am, may mga pictures tayong ipapakita mamaya.
Oo.
Pero marami tayong applications ng mga free-falling bodies natin.
Yes.
We can see more
Ma'am
later.
Liza?
So,
yan yung isang example, ma'am, yung ating projectile motion. So, ang topic natin for today is all about the projectile motion. So, ano ba yung... Yes, which is also a uniformly accelerated motion. So, ano ba ang ating mga objectives?
Okay, Ma'am
For
Risa,
today.
tingnan nga natin yung mga objectives natin. Unang-una, we have to describe the horizontal and vertical motions of a projectile and investigate the relationship between the angle of release and the height and range of the projectile.
Okay. So, meron tayong ipapakitang video clip.
Siguro ibalik natin kay Ma'am Donna at kay Sir Ronnie itong video clips dito kasi may kinalaman sa hilig ni Sir Ronnie na kasama yung mga teachers ng Doña Aurora every afternoon yata.
Oo.
Sir Ronnie, sino ba tong player na to?
Okay, sino ba yung player na yan? So yan si Stephen Curry. So, magaling yan, kaso nga lang natalo sila kahapon.
Ito naman. Ganun ba?
Natalo sila kahapon ng... Di ba, may game 5 pa daw, sabi nila.
Updated talaga, Sir Ronnie.
Anong game yan, Sir Ronnie?
Cleveland ang kalaban nila. Baka matagal na yan. Baka 2017 pa tong game na to.
Hindi yan yung latest.
Hindi yan yung latest nila kahapon.
Sige, play natin.
Play natin.
Ayan. So, titira siya. So, observe natin yung nangyari doon sa ball.
Bakit parang nag-ano?
Oo, parang naglalag siya. Ulitin natin.
Sige, paulit natin.
Yan.
Yan.
Shoot kaya?
May shoot kaya yan?
Naghang!
Sa tulo na.
May papasok yan.
May shoot yan, ma'am.
Okay.
Parang feeling ko tatama siya sa board.
Marunong siya kumanta.
Bago makarating sa ring.
So, do you believe, Sir Ronnie, na ang basketball, volleyball is a game of science?
Yes, ma'am. Meron pang isang commercial ba yun na yung engineer na hindi niya may shoot yung bola hanggang sa sinukat niya yung distance, yung angle pag-release.
Oo. So kung wala kang skill pero pwede mong daanin sa
Science.
Diba?
Okay.
Compute.
So, dyan sa basketball, pwede kindly describe.
Describe.
Yes, yung pata dinaanan ng bola. Ma'am Donna, anong paki-describe mo, Ma'am Donna?
Gusto niyo ako na lang mag-describe?
Yes.
Meron na bang sumagot, Ma'am Jen? Baka unahan ko.
Sige, mga anak, sagot na kayo. Ano ang path na dinaanan ng bola?
Describe lang naman nila.
Describe nyo daw.
Sige, describe natin.
Oo.
O kung sa akin, Sir Ronnie, siya, curve.
Pa-curve.
In our common language, may kurbada siya,
May kurbada siya, yes. Kumbaga, hindi siya straight, ma'am.
Yes, hindi
mahirap
straight.
na mag-shoot kapag ibabato mo lang yung bola mukhang...
Paano mo i-release yun, Sir Ronnie, pagka pataas lang ang tirada niya?
Hindi ko pa napanood sa Ronnie na naglaro ng basketball sa gym.
Magugulat ka na.
Okay.
Next. Yes. Next, ma'am.
Okay, so...
Yan naman. Sige, yan naman,
wait
ma'am.
lang, merong nagsumagot kanina. Sabi ni Christian Vino. It's like a parabola. Wow, mathematical.
Parabola.
Equation.
Pero
may question mark siya.
Yes, napakaganda ng sagot niya.
Napaka-active naman ni Christian. Pangalawang best ng sumagot.
Next.
Okay, so sa mga susunod na slides natin naman, makikita natin, Ma'am Riza, tingnan nga natin mga susunod na slides. Sige lang, ipasadahan lang muna natin. Yan, tapos yung pangatlo. Yan. Balik tayo sa una, Ma'am Riza. Okay, Ma'am Jen, ano kaya yung similarity nung mga pictures na pinakita? Sige, Ma'am Riza, yung sunod na slide. Ano kaya ang similarity nung, motion na ba slow?
Yes. Doon kasi, ma'am, sa kaninang basketball, yung pag-shoot ni Stephen Curry, naka-slow mo siya. Pero dito sa mga next na slides natin, ay pinapakita kung saan mismo yung posisyon ng object doon sa every time interval, siguro every second kung nasaan na siya, no? Hindi siya nakalinyad na marami diyan. Isa lang yung object pero pinakita lang yung position niya every second.
Hanggang sa makalanding siya.
Oo, hanggang sa makalanding siya. So mapapansin natin diyan katulad ng sinabi kanina ni Christian, it's like a parabola or in common term, it follows a curved path, no? Yan. Then, upon reaching the highest point, di ba, eventually, it will go down. Pero naka-curve pa rin siya. Hindi siya go down na biglang pababa.
Parang siyang rainbow.
Yes. Ayun, naka-rainbow siya. Parang ganon.
Ganon din dito, ma'am, sa motion of water jets coming out from the nozzles. Ganon din, curve din yung kanyang, yung kanyang shape.
Ayun. So, next. Ayan. So, yung tawag natin sa mga object na yun, ma'am, ay projectile.
Ano ba talaga, ma'am Jen?
Ano kasi yan? Accepted yung
malito-lito na tayo
projectile and projectile. Depende lang yan kung British accent ka or American accent. Ano?
Okay.
Oo. Ganun
Saan
yun.
ang British?
British ata, projectile ata. Oo. Yan. So, projectile na lang tayo. Okay.
Projectile.
So, it's any object which is projected in the air is called as projectile. So, example, kung naghagis ka ng bola, so yung bola na hinagis mo is a projectile. Yung bola lang mismo, na hindi mo naman pa hinahagis, hindi pa siya projectile. Ganun
So, only
yun.
when it's projected in the air,
Yes.
bago siya pwedeng tawaging projectile.
Exactly, ma'am. Yes. Next. Okay, so a projectile follows the projectile motion. So it's a motion in which an object is thrown near the Earth's surface and it moves along a curved path under the action of gravity only. Yung word na gravity only, ma'am. It's only acted by gravity. Yan.
Okay, titingnan naman natin ngayon yung mga terms that are related. Ay, assumptions muna tayo, yes. Assumptions used in the projectile motion. So yung unang-una, the effect due to air resistance is negligible. So bago natin ipaliwanag ito, Ma'am Jen, siguro kailangan muna natin linawin kung anong ibig sabihin ng mga salitang negligible at saka yung air resistance.
Yes, ma'am.
O yung negligible, Ma'am Jen, ano pa ibig sabihin yan? Kasi halos lahat ng three assumptions natin, first three assumptions natin, made use of the word negligible. So,
pwede nating sabihin na pag negligible, hindi na siya pinapansin. Kasi masyadong malit yung value niya.
Parang minsan ako,
ganun
hindi ka
ba?
importante.
Pag neglected.
You're being neglected because you're
So,
not important, parang ganyan.
Yan. So, dito sa projectile motion, ay hindi mo na pinapansin yung air resistance. Ano ba yung air resistance, ma'am?
So, halimbawa, siguro yung mga estudyante nating mahilig mag-bike.
Okay.
Diba minsan paano ba yan natin ipapaliwanag yun, Ma'am
Kapag
Jen?
malakas ang hangin. Di ba kapag malakas ang hangin, medyo nahihirapan tayong magpedal. Kasi yung air resistance ay greater. Pero dito sa projectile motion, hindi na natin papansinin yung air resistance. So,
the effect of air resistance.
Assuming na walang air resistance. Yan, dito sa ating projectile motion. Kasi kung true to life, meron siyang kahit konti, ma'am. Pero dito sa ating topic for today, it is neglected muna. Okay.
The second one naman, the effect due to curvature of the Earth is negligible. So meron naman tayong important term na kailangan i-consider dito. Again, yung negligible, malinaw naman na yan kanina. We have the term curvature. So yung shape ng mundo natin ay somewhat spherical.
Yes.
Ang tawag din, pa-curve din siya. But this has nothing to do with the effect of projectile motion.
Hindi niya fina-follow yung curve ng Earth, kaya siya nag-curve, hindi gano'n. Hindi sila related.
Oo.
Then, third, the effect due to rotation of the Earth is negligible. Yan.
Kasi alam natin yung rotation din ng mundo natin, halos ang tawag doon, parang pabilog-bilog din.
Yes.
But it's also negligible here.
Opo.
And
Yan.
lastly,
the acceleration due to gravity is constant over the range of motion. So, at any point in the projectile motion, the acceleration due to gravity never changes. So, 9.8 meter per second square pa rin siya kahit nasa ang point doon sa yung curve path na yon. Okay.
Next, Ma'am Riza, we have here an idealized model of a projectile motion.
So this one, neglecting air resistance, it follows a curved line. So makikita natin dyan yung mga symbols, yan, may arrow, may angle, yung theta natin dyan. So may H, may R. Ano ba yung mga yon? So we'll go deeper
As we move on.
yes. Yan, isa-isahin natin ang mga yan.
Okay, next Ma'am Risa, tingnan natin ito, ang tinatawag nating trajectory. It's the parabolic path followed by a projectile in air. So that's called trajectory.
So yung tinawag yung sinabi kanina ma'am na curve path, yung parabola is actually the trajectory.
Trajectory.
Yan.
Okay? So kung titingnan natin yung bola dyan, as it's being thrown, siguro, it follows that trajectory na curve path natin.
Yes. Next ma'am.
Next Ma'am Riza, may we have the next one. We also have the
Point of projection. So the point from which the object is projected in air is called as point of projection. Kung mapapansin nyo dyan sa ating screen, yung red na dot doon sa may left side, yun yung ating point of projection. Yan yung pinaka-origin niya ng projectile bago siya i-launch. Ano ma'am? So, yun yung, ang tawag doon ay point of projection, kung saan siya bago siya i-launch. Okay. Next.
We have also the velocity of projection. So, this one, the velocity with which an object is projected in air is called as velocity of projection.
Okay. Another term dyan, ma'am, is yung initial velocity. Ano? Yung velocity na, or yung speed niya, ng pagka-launch sa kanya. So, halimbawa, kung kung golf, kung gaano kabilis yung pagpalo mo dun sa bola, yung bilis dun sa pagpalo mo ng bola, yung speed na dala-dala nung bola, nung golf ball, ay yun yung kanyang velocity of projection.
Yes.
Okay. So, meron pa dyan, mayroon pa, next dyan, Ma'am Riza, is yung angle of projection. Ito naman, the angle with the horizontal or in reference to the ground at which an object is projected in air, yan, is called the angle of projection. So, makikita nyo dyan yung angle sign, yung theta natin. So, yan yung angle, kung gaano ba siya kalaki yung angle niya from the ground. So, pwedeng magbago yan, ma'am. Pwedeng 20 degrees, 45 degrees, 60 degrees, ganyan, 90 degrees, yan.
May papakita tayo mamaya, Ma'am Jen.
Oo. Yes. Titignan natin mamaya kung meron bang kinalaman ang angle of projection sa range and height ng projectile natin. Yan. Next, ma'am. Ito, time of flight. So, alam natin na ang mga bagay na initya or hinagis ay mag-stay sa ere ng ilang segundo. Okay? So, yun yung tinatawag nating time of flight. So, the time taken by a projectile to cover the entire trajectory is called the time of flight.
Maganda sigurong i-relate natin kanina yung pinakita nating pag-shoot ni Stephen Curry
Yes.
sa unang video clip natin, yung gaano katagal yung tawag doon from its launch hanggang sa makakarating sana siya sa may ring. Tama ba ako?
Kaso dun sa video kasi naghang siya, no? Pero in real life, syempre bababa yun, no? Babagsak yun. So yung time na pagbagsak niya ay yun yung end nung time of flight. So beginning is yung paghagis mismo, yung release dun sa ball, and then the time in which it reached the surface is that end time. So, ilang segundo yon, pagitan nun, ayun yung time of flight.
Yan ang nakakatuwa dati nung mahilig-hilig pa ako manood ng basketball nung bata ko. Yan yung talagang inaabang-abangan ko. Kapag yun yung oras ay malapit nang matapos and then may biglang nag 3-point shot, parang ganyan. Tapos i-slow mo yung i-slow mo yung pagpasok ng bola dun sa ring. Tapos swak siya na nakarating siya in a specific span of time bago mag-ring yung buzzer.
Ay, may tanong pala ako, Sir Ronnie. Kapag halimbawa 3 seconds na lang sa time, ay ang tawag doon, yung yung shot clock. Tapos last na 3 seconds na natitira. Tapos ang time of flight ng bola is 5 seconds or 4 seconds ka muna lang. So number 3, nasa ere pa lang siya, hindi pa siya na-shoot.
Counted
ba yun?
Yes, ma'am. Basta wala na sa kamay ng shooter.
Okay. Yung time ng release niya ang
Nakakatawa lang kasi.
Oo, kasi may ganun yung think, sabi na saka pa lang shoot, counted pa pala yun. Okay. Pero ma'am dito, ay sa time of flight natin is meron siyang symmetry dito. 'Di ba? So yung oras niya papunta sa highest or yung time of flight niya papunta sa highest point is equal dun sa oras from the highest point to the ground. Okay. So kung so halimbawa, 1 second hanggang dun sa highest point, another 1 second pababa. So yung total time of flight niya is 2 seconds. Yan. So kung gusto mo lang kunin yung time of flight niya hanggang sa highest point, so divided by 2 mo na lang. Okay? Tama ba yun, ma'am?
Kung hindi ako nagkakamali, meron further explanations mamaya si Ma'am Donna at Sir Ronnie tungkol dun sa symmetry.
Okay, yes. Yan. Next tayo. So, ito ma'am, yung maximum height of projectile.
So it's the maximum vertical distance traveled by the projectile from the ground level during its motion. Yan ang pinakamataas na point na nare-reach ng isang projectile in air. So in this illustration, makikita natin dyan yung ang tawag doon, double-headed arrow natin pertaining to the height or the
Yung
vertical
H,
distance ng ating projectile. May iba pa bang tawag dito, Ma'am
Yes,
Jen?
ma'am. It's also the displacement in the Y component.
Or the vertical.
Yes, or the vertical component. So, yan yung displacement niya pataas. Yan. Or the H, the maximum height.
Okay, next, Ma'am Riza, we also have the horizontal range of a projectile. So it's the horizontal distance traveled by the projectile during the entire motion. Kung yung ang tawag dito, yung maximum height kanina, yun yung Y component natin. Ito namang horizontal range natin, it's the X kumbaga, di ba?
Yes.
So we have there an arrow showing us the range, di ba? Sana meron tayong point from point to point.
Doon sa red na lang, red dot. Yun yung kanyang point of projection.
Tapos, hanggang doon sa kung saang point nakarating yung projectile natin. That's the horizontal range na may papakita rin natin mamaya doon sa ating simulation at the end of this discussion. Or before we end this discussion.
Okay.
Question.
Ay, iba pala yung pinipindot. Ma'am Riza. Ayan, bago tayo mag-move, ma'am, tanungin muna natin ang ating mga estudyante. Kung talagang
nandyan pa
sila at nakikinig pa sa atin. So, meron tayong question number 1. Just key in your answer in the comment section. So, ano yung tanong natin, ma'am?
If it takes, ito yung tanong, para sa mga nakikinig lang sa radyo, if it takes 5 seconds,
Sa live.
pwede naman hindi pwedeng sumagot pala yung mga nasa radyo? Wala tayong binigay na one number, ano? So, if it take, pwede kayong mag-solve mga anak and then, ang tawag doon, picturean lang ninyo yung sagot and then you can send to your subject teacher naman. If it takes 5 seconds for a projectile to move up to the highest position, how long will it stay in the air? Ulitin natin. If it takes 5 seconds for a projectile to move up to the highest position, how long will it stay in the air? Okay, you may now key in your
may
answer
sumasagot na.
in the comment section.
Oo, ang galing-galing nila, Ang galing.
Ilan ang nakita ni Ma'am Riza?
Oo. Ang unang sumagot ay si Christian Vino ulit ng 9 Darwin. Very good. Ang sabi niya ay, it will stay for 10 seconds in the air. Tama. And then, sumagot din si Aldrin Mamaspas ng 9 Pasture, 10 seconds. Natasha Peraltan, 9 Darwin, 10 seconds. Melanie Sagusyo, 10 seconds. Ayan, lahat na sila, ma'am. Puro 10 seconds. Ayan, dami nila, Ayan, ang
Very
galing-galing.
good. Nakikipag-participate ang ating mga learners. So,
Yes.
tama ba sila? Tama sila?
Tama sila. Kasi nasabi natin kanina, it takes 5 seconds to move up. Hanggang bumaba siya, that's another 5 seconds. So, total, 10 seconds. Ayan.
Okay.
So, ma'am, nabanggit natin kanina ay, di ba kapag hinagis natin ng isang bagay, it will move upward. At the same time, it will also move forward kung hinagis mo siya at a certain angle.
Yes.
Diba? So, masasabi natin meron siyang maximum height, that's the displacement in the Y-axis or Y component. vertical component, and at the same time, it moves forward. So that is the range or the displacement in the horizontal dimension. So, meron siyang dalawang dimension, ano ma'am? So, masasabi natin na may x or vertical and horizontal dimension. So, to explain to us further these two dimensions, we have Ma'am Donna and Sir Ronnie.
Okay, sige.
Ayan.
So, is horizontal and vertical motions are interdependent to one another. So,
Question.
ah,
That's a question, Sir Ronnie.
Oo,
yes.
Independent.
Kung interdependent ba sila sa isa? So, sa live stream, makikita nyo yung pink and
Yellow balls.
yellow ball. The vertical motion doon sa horizontal.
Sir Ronnie, ulitin natin dear learners, remember that a projectile has two components.
Yes.
Tandaan natin yon. Kaya nakikita natin dito sa diagram natin yung yellow ball that represents the forward motion of the projectile and the pink balls depicting the vertical motion of the projectile, which are independent from one another. So, meron siyang dalawang component na magkaiba. Di ba, Sir Ronnie?
Yes, ma'am.
So, yung sinasabi nating horizontal component, usually, we name it as the X.
The X and the
X component.
Yes.
And the
Vertical
vertical
component
component, we name it as, or it is represented by the Y component. So, yung X and Y component, Sir Ronnie, di ba, pwede siyang maging displacement or the velocity.
Yes.
Diba?
Yes, ma'am.
Okay. So, naintindihan nyo ba ito? Naintindihan kaya nila ito?
Yes, ma'am. Basta
Diagram
isipin nila,
natin?
intindihan nila independent sa isa't isa.
Describe natin yung bola, Sir Ronnie.
Yes.
Yung bola galing sa taas.
Yes, ma'am.
Yan, wag kayong mahihilo kasi yung unang diagram kanina, yung unang na-i-describe natin na projectile, it was launched from the horizontal.
Yes, ma'am. So, anong napansin mo dyan sa pink and yellow, ma'am? Pink and yellow ba?
Okay, so describe natin, Sir Ronnie.
Yes, ma'am.
So, from the top, kasi doon siya na-launch, kasi there are projectile which are launched at a certain height.
Yes.
So, doon siya sa taas manggagaling. For the first part of its downward motion, makikita natin yung distance traveled, which is represented by the lines, the blue lines na nakikita natin dyan, smaller
Yes,
siya.
smaller in
Closer,
space.
closer.
Yes. Yes.
No, the lines are closer, which would mean that the distance traveled for the first downward motion of the projectile or the object that has fallen down is smaller from the rest of its travel as it reaches
Yes,
down.
the grand, ma'am. So, mapapansin natin dyan, ma'am, sa bandang yung sabi ng last three walls na natin, pink and yellow, ma'am, medyo magkakalayo na yon yung distance nila.
Yan yung sinasabi natin kanina, Sir Ronnie, na constantly
Yun,
accelerating.
rotated motion.
Okay. And later on, makikita natin na yung pag-accelerate niya, yung change in the velocity is the same all throughout its time
of light.
travel.
Yes.
Okay.
Next. So, projectile, ano na yan? Since projectile
Yung ating X.
yan, yan X and horizontal, that is the range, while the vertical,
It's the height.
the height.
Forward
Yes.
motion. Yan. So, horizontal velocity component. So, there are two, aside from the displacement sa Ronnie
Yes,
na
ma'am.
X and Y, meron din tayong two independent component which are the horizontal and horizontal component lang ito ng
Yan
velocity
sabi mo
niya.
kanina, ma'am, na yung component niya pa pwedeng distance at pa
Oo,
pwedeng
pwedeng
velocity.
Okay, so never changes. So from the start of its flight up to the time it falls and reach its final point, pare-pareho ang horizontal velocity, or we term this as the forward velocity or the forward motion or the X.
Yes, ma'am.
Or
That
the
constant
VX,
throughout the
which is
travel nila.
constant.
Yes.
Pare-pareho yan at different time interval.
Yes, kung nagsimula siya ng 9 meter per second throughout 9 meter per second, kung 10 or throughout 10 meter per second.
Okay, so this means the initial horizontal velocity equals the final horizontal velocity. So pag nakikita natin dito sa parabola natin dito, yung initial natin, yun yung nandoon sa end.
Yes.
Sa initial point ng parabola and the final, yun yung last point ng parabola.
So kung initial niya, ma'am, is 10, the final is also 10 meter per second. So gravity does not work. Pababa lang siya. Next, ma'am.
So, constant siya.
So, vertical velocity.
Yung second component.
The second component naman, ma'am, is the vertical velocity. Distance sa pinag-uusapan natin.
Sir Ronnie, remember natin, dalawa ang motion natin ng vertical. Pwedeng up, pwedeng down. Pwede ring pababa lang.
Yes, ma'am.
Okay.
So, in this case, projectile, kapag vertical, meron ng force na nag-a-act. That is the gravity. Kanina kasi sa vertical, sa horizontal, hindi siya inaapektuhan ng gravity, tama, ma'am?
So dahil meron na siyang force, meron ng acceleration.
Yes.
So following the second law of motion, kapag may force, merong acceleration. Okay? So this time, nagkakaroon siya ng acceleration, Sir Ronnie. So, describe natin yung travel niya.
Yes.
Taas muna.
Sige, sa pataas muna tayo, ma'am. Kung mapapansin natin yung distance niya, ma'am, doon sa kung bolya, ano napansin natin, ma'am, sa distance niya?
Yung green ba, sir, ang inaano natin? Yung green o yung black mo?
Yung black muna, ma'am, kitang-kita nila. Yes. Yes, ma'am.
Sige, pababa siya.
So, ano mapapansin natin dyan, ma'am, sa
So,
black?
yung distance niya pababa, katulad nung unang diagram natin kanina,
Yes, yung pink and increasing.
Okay.
Pero pag sa upward naman siya,
Sa upward siya, napapansin natin yung green parabola natin dyan, mapapansin ninyo na yung habang papataas, no, what happens to the distance traveled, makikita natin yung arrow going up, yung first arrow is nearer the X, sa
Yes.
horizontal surface natin, and then yung second arrow going up dito sa, when we are facing the graph, or when we are facing the diagram, yung arrows, we are talking about the arrows on the left side.
Left side, ma'am.
Okay. Yung second arrow is somewhat, or has somewhat a greater distance from the first arrow compared to the distance of the first arrow from
yes.
the
Ground. Yes, ma'am.
Okay. So, ibig sabihin, Sir Ronnie, pag paakyat yan eh. Yan yung kaka-launch mo ng projectile. So, ibig sabihin, once you throw something going up, pwedeng yung bola, pwedeng yung hinit mong bola ng volleyball, mabilis siya sa baba, but as it rises, no, and it travels going up until it reaches its highest point, anong nangyayari sa motion niya, Sir Ronnie?
Bumabagal, ma'am?
Oo, bumabagal.
Yes.
Kasi nakikita mo yung distance traveled by the second and the third arrow, mas greater.
Yes. So, as the
Feeling
Yes. Doon na meron ng acceleration dito sa vertical component. Doon tayo sa horizontal, zero acceleration yung kasi constant. Yes, constant kasi yung velocity niya. Kung babalikan natin sa grade 8 nila, ang acceleration kasi is change in velocity. Since na wala siyang change in velocity, therefore talaga magsisiro ang acceleration niya. Okay, next. O yan na, yung projectile natin, ma'am.
Yung ano ay?
Motion diagram of a kid football.
Okay, so let us analyze the projectile motion of a kick football. Ayan, ma'am. Next, ma'am. Okay, so ito yung on the left side ay yung projectile motion mismo. On the right side ay naman yung pinaghiwalay since sila ay independent with each other, ay pinaghiwalay yung vertical motion and horizontal motion nung ball kanina. So, isang ball lang ina-analyze natin dito. Okay. So, on the point of projection, andun pa lang sila, nasa point 0, sabi na natin. And then, comparing sa vertical and horizontal motion niya, pareho silang nasa point 0. Okay. Next slide, ma'am. After another second, so ito na yung next point niya. So nandun na siya sa medyo taas. Okay? So ang kanyang height ayun sa vertical motion, and then compare natin yung kanyang horizontal motion ay nag-move na rin siya to the right. Ayan. So yun yung separate na motion niya in vertical and horizontal. O, next slide naman, ma'am. After another second, so 2 seconds na siyang nasa ere, andyan na siya sa kanyang maximum height. So kanyang maximum height or tama, yung h natin kanina, so the displacement in the vertical component, doon na siya sa maximum height, and then sa horizontal motion niya naman ay andun siya sa halfway. Tama, ma'am? Okay, nasa halfway naman siya. O, next, ma'am. Yan. Pagkatapos ng another second, so 3 seconds na, third second. So, nandun na siya sa, pababa na siya, di ba, ma'am? So, kanina, na-reach niya yung kanyang maximum height. So, pababa na siya, makikita nyo sa may vertical motion niya, dun sa pataas natin dyan, ay bumaba na rin siya kumpara dun sa kanina. And then, sa horizontal motion niya, continuous siya na nag-forward.
About 3/4 na.
Yes, about 3/4 na niyang marireach yung kanyang end. Okay, next naman. Ayan, after 4 seconds, andyan na siya sa ground. So, ang kanyang vertical motion ay syempre nag-back to 0 na kasi bumalik na siya. And then, ang kanyang horizontal motion, this is now the range or the distance in the x component. So, na-reach niya na yung kanyang maximum range. So, yun siya. Then, makikita natin yung pinagsama-samang analysis na natin, Ma'am Riza. Ayan. So, ayan na siya at different time interval. So, makikita natin dito, mag-base tayo dun sa, ma'am, so, sa highest point niya. So, tignan natin yung highest point. So, yung point na adjacent sa kanya on the left and the right, anong mapapansin natin dyan?
Pantay sila, di ba?
Okay, pantay sila. So, and then, dun sa pababa ulit, yun sa origin and the end point, mapapansin natin yung distance nila from the, yung distance nila from the highest point. So, yun sa pinakagitna natin, pareho, di ba, ma'am?
Yes.
The same. So, we can apply the concept of symmetry in this projectile motion. So, yung ating magiging reference point ay yung kanyang highest point or yung kanyang height, and then, yun yung imaginary line. Maglagay na lang tayong imaginary line natin doon. Then, all the points on the left are the same, mirror siya nung nasa right.
Parang yung paru-paro, Ma'am Jen.
O, paro-paro G.
Yung paru-paro natin, yung side ng kalahati ng pakpak ay
Yes,
pareho lang dun
pareho.
sa kalahati.
Yes, tama
Sa
yun.
arts, pwede natin i-apply yung symmetry din, di ba? Parang
Opo.
ganyan lang din ito sa may ano natin.
So, kanina ma'am, ang sinabi natin ay yung distance. Ano,
Yes.
yung layo niya, tinitignan natin. Pero applicable din siya sa, saan ba siya applicable? Sa velocity, di ba? Sa velocity niya. O, so, kung ano yung velocity niya sa initial, sa point, initial velocity niya, yun din yung kanyang velocity just before it hits the ground. But, yung sign convention natin, ma'am, it will be negative, tama?
Yeah, pababa.
To indicate the downward direction. Ayun.
Yung time ba, ma'am, applicable din dyan?
Yes, ma'am. Ganon din yung time. Kasi, ma'am, sa highest point ay nasa halfway siya, no? So, yung time mo, yung total time mo ay i-divide mo lang siya into 2. So, ganon po yun, ma'am. Next. So, meron tayo ulit question na sasagutin ng ating mga estudyante na nakikinig ngayon sa ating live. Kung medyo kumonti na, pero ayan, tuloy lang natin, no? So, our question, what is the acceleration of a projectile at the highest position where its vertical velocity momentarily becomes 0? So, pag nandun na kasi siya sa highest point, di ba, bababa siya pagkatapos, pababa na siya. So, dun mismo sa punto na nasa highest position siya, ay naging 0 yung kanyang velocity. Kaya after nun, bababa na siya. The question is, what is the acceleration of that projectile at that highest position? Sagot na mga anak with the correct unit, di ba, Sir Ronnie?
Dapat mayroong unit, correct unit.
Dapat may correct unit tayo. Sagutin. Habang hinihintay natin yung sagot sa ating comment section, pwede na tayong mag-move, Ma'am Riza. Ayan. So, important conclusion natin. Ayan, pakibasa, Ma'am.
So, we have here two of important conclusions from the lesson. We have A, horizontal motion with constant velocity, and then vertical motion with constant acceleration.
Uy, medyo na bahagyaan dito yung sagot sa kanina. Merong clue dyan na vertical motion with constant acceleration. Acceleration siya. Okay, so next. Wala pa namang sumasagot, mamaya siguro baka pinag-iisipan pa lang nila.
Yung simulation natin,
Ayan, may simulation natin, Ma'am Riza. Ayan. So, this simulation is available in FET, Colorado. So, pwede nyo i-search to mga anak para kayo mismo ay ma-manipulate nyo siya. Ayan. So, meron tayong cannonball na pwede nating i-adjust ang kanyang angle of projection and at the same time, yung initial speed na dyan sa baba. Yung initial speed niya. Okay. Try muna natin, ma'am, ano unahin natin dito, Sir Ronnie?
Yung angle niya.
15 meter per second.
Ang constant ng ating angle.
Constant mo. Yes.
45.
Okay.
At the angle, wag mo ng 45. Gawin nating
50.
15. 50.
Okay, 50. 50. 50, ma'am.
Yung mas mababa sa 45.
Ay, mas mababa ba? Sige.
Juicy.
Oo. Pwede kasi natin itong bago-baguhin. Okay. Wait lang habang natin ituloy ang simulation natin. Meron na kasi mga sumagot. Okay. Ang sagot nila ay constant. But we are looking at the value. The exact value. So, yung mga anak, exact value with the correct unit. Ayan. So, balik tayo sa simulation. Ilan yung ating initial speed, ma'am?
15.
Okay, 15 meter per second. Projected at 30 degrees from the ground. Ayun. So, yun, lumampas sa target. Okay. So, ayan siya, no? Hindi naman mabubura yan. Next, ano naman?
Yung angle ang
25 meter per second. Initial speed muna tayo. Constant ang angle natin. Okay.
Go.
Uy, hindi na makita. Medyo i-zoom out. Zoom out mo, ma'am. Yung negative dun sa taas. Para makita natin. Yun sa upper left. Yan. Ayun. So, yun siya.
Layo ng diferensya.
Yung projectile motion, yung trajectory na yan ay binigay ng initial speed na may 25 meter per second. Then, try pa natin ng isa. Mas mataas or mas mababa? 15, 25, and then 45. O, try natin increase pa ang ating initial speed ng 45. Ay, hanggang 30 lang siya. Hindi niya nakidaya. So, 30. O, sige, launch natin, Ma'am Riza. Yun.
Okay. So, ano masasabi mo dyan, Ma'am Jen?
Okay.
Sa, ano yung effect
Yes.
ng initial speed or yung speed ng object doon
sa range. Sa range. So, makikita natin na upon adjusting the initial speed, so from the lowest, which is the 15 meter per second na initial speed, siya yung may pinakamababang range, no? Siya rin ang may pinakamababang height. While habang pinapataas natin hanggang dun sa may 30 meter per second, siya yung may pinakamalayo at the same time pinakamataas naman na height. Given ang meron siyang constant angle of projection. Yan. So, may kinalaman yung initial speed, ano?
If kung ang babaguhin naman natin, ma'am, is yun, angle of projection. So, saan kayo angle magkakaroon ng pinaka malayo ang range?
Sagutin natin?
Yes.
Wait lang. Wait lang muna. Ma'am, yung ang tawag dyan? Eraser. Pindutin mo yung eraser, yung yellow. Yan.
Sige, constant natin yung speed at 10.
10. Yan.
Unahin mo muna siya sa 15 degrees.
15 degrees.
Hindi, kahit 30, Sir Ronnie, para tatlo lang. 3 point lang tayo. 30.
Okay, launch. Yun.
Yan. 45. Next. 50? 60. O, sige, 60. Sir Ronnie, dagdagan natin 75. Gusto mo? Okay, 75 para walang masabi. Ma'am Jen. Generalization.
Okay, so given initial speed na 10 meter per second, ang minapinipulate lang natin ay yung angle of projection. So, anong mapapansin natin dun sa 4 na projectile na nilaunch natin? So, makikita natin dyan yung kanilang mga trajectory. Ano yung
Iba-ibang height.
Iba-ibang height, iba-ibang
Iba-iba.
range. Okay. So, yung mapapansin ko na ang may pinakamaiksing range or pinakamalapit lang na range ay yung huling nilaunch natin. 75. Which is 75. At the same time, siya rin yung pinakamataas, ma'am? While yung pinakamalayo naman ay yung 45 degrees angle of projection. So,
Actually, yan yata yung maximum.
Oo.
The angle where you could launch with with the highest range.
Yes.
The maximum range.
Is projected at 45 degrees. So, lagi niyong tatandaan yan, mga anak, kasi laging tinatanong yan. Hanggang sa board exam, tinatanong yan. Oo. So, habang so parang, tawag dito, 1 degree hanggang 44 degrees, then, banda dito siya, then 45, marireach mo yung maximum. And then, pag tataas ka na sa, halimbawa, 46 hanggang hanggang 89 degrees ay papalapit ka na naman ng papalapit. Yung range mo, yun yung ano doon. Kahit try nyo, di ba, sa hose. Pag sa bahay, hindi abot yung hose ninyo sa mga plants ninyo, mga halaman, anong gagawin? Imamanipulate nyo yung angle of projection nyo. Para medyo pinakamalayo yung ma-reach niya, i-project nyo at 45 degrees. Para naman, ma'am, medyo lumakas. Anong gagawin? Medyo iipitin mo naman, para yung velocity niya, kasi yung pressure niya, so bibilis yung kanyang initial speed. So, yun yung ating, pwede nating ipakita dyan, sir, yung magnitude niya. Dito, ma'am, yung sa may, dun sa taas niya, yung may green-yellow. Oo, burahin mo muna yung yan, trajectory natin. Tapos, yan. Tapos mag-launch ka ng isa. Sige nga. Try nga natin, ma'am. Ayun. Try mo nga, ma'am, pinutin yun kanina. Ay, ano pala yan? Medida niya pala yan. Sorry. Okay, so, time na pala. So, yun ang ating important points or concepts regarding the projectile motion. Actually, meron pa itong mathematical part niya, yung magsusolve na talaga tayo ng height, ng distance in the y and distance in the x. So, meron pa, yan. Pahapyawan natin yung ating slide, ma'am. Yes. Okay. So, Sir Ronnie.
Sige. So, ayan. Ikaw natin tong table.
Sir, unahin na lang natin yung horizontal motion.
Sige, horizontal motion.
Kasi siya, di ba?
Sige, constant siya. So, that is C10. Then, how about the time, Ma'am Donna?
Sa vertical motion.
Okay. Yung sa time natin, sa highest position.
Unahin natin sa ulit, ma'am. Velocity in the vertical. Yan, bago tayo
Sige. So, velocity sa
highest position is 0.
Yes, kasi atras na
Okay, kasi ito yung point na nasa pinakamataas siyang point.
Yes.
Okay. So, and then yung kanyang final position, nagiging negative meter per second.
Kasi pababa.
Nandun na siya sa baba.
Yes, pababa na siya.
Yung negative is given by the downward direction.
Yes.
Yun yung, actually, wala naman talaga tayong velocity
yes.
na negative. But the negative sign there means that it had reached the opposite direction. No?
Of the initial position, ma'am.
Of the initial position. Okay. So, doon sa time, Sir Ronnie. Sa highest position niya sa time is 3. Okay. And then, ito yung time natin, mga anak, pag nandoon siya sa highest point, yung kapag makita natin yung bell kanina, yung nandoon siya sa tuktok, yung highest peak, 3 seconds siya nakarating, no? Sa taas. And then, sa final position, sabi natin kanina, symmetrical. So, what is true to the left side of the diagram is true to the right side of the diagram. So, another 3 seconds. So, yung final position mo is 6.
6, okay.
Paano nakuha yung time dyan, ma'am, sir?
Paano nakuha yung time? Every second, ma'am? Yes. Yung 3. Every second?
Ay, hindi. Kasi
Yung 9.8 na meter per second natin,
Ma'am
ma'am,
Jen,
na
nakuha yung
acceleration.
time
No?
kasi based from the velocity.
Yes.
No, yung velocity kasi natin on its initial position is 30 meter per second. When you are given that initial velocity, you can only have a time travel going up at 3 seconds.
So,
No, kasi for every second, there is an estimated 9.8 meter per second increase in the velocity. So, until such time, maubos mo yon kasi
Yes,
mag-stop
magzi-zero na siya.
Magiging
Yes, ma'am.
zero siya when it reaches the 3 seconds going up.
So, yung sabi ni Ma'am Donna 9.8, tama yun pero dito kasi ang ginamit natin ay 10 para mas mabilis lang tayong mag-multiply.
Ni-round off lang natin.
Pero tama, correct yung sabi ni Ma'am Donna, to reach the maximum daw, 3 seconds yung kanya.
Okay, Sir Ronnie, hanggang saan siya aabot?
Hanggang siya,
Yung displacement natin, sir.
so, ano formula natin dyan? Yes, 30. Just multiply velocity times time. So, 30, then 60 then. 10 times 6. Yes, nadagdagan. So, kalahati, 30, 30, 60.
Yan yung mga anak, yun yung kung saan siya umabot on its forward motion. Yung gaano siya kalayo papuntang paharap. Ano, sir? Okay. Yung, ayan na, sir, yung
The maximum height. Ng
45 meters. Okay. So, yan ang ating simple computation ng ating projectile motion. So, on the displacement in the final position is 0 meters kasi bumalik na siya sa baba. So, wala na siyang height doon. So, that's it. Ang ating lesson. So, quick summary lang tayo.
Ma'am Jen.
Yes po.
May tanong sila.
Ay, may tanong.
Saan natin pwedeng i-apply
okay.
itong lesson natin sa
Projectile.
projectile? So, una, sa mga sports, di ba?
Yes.
You can already estimate the length of time a ball will fly or will stay in air bago siya makapasok sa net o ma-hit o makapasok sa maka-goal, ganyan, sa mga football. Diba?
Golf, malaking application ng golf.
Sa golf.
Yes,
Kahit
the golf.
Sa volleyball.
Pati yung angle nila, ma'am, not only the time, siguro.
Oo,
yung
yung
angle,
angle.
halimbawa sa pagsushoot,
Yung
ganyan.
angle of release.
Oo. Kapag sa volleyball naman, halimbawa na dun ka sa harap, wag mo nang ano yung tawag dyan?
I-kill.
Yung angle mo, wag mo nang i-45 degrees.
Oo, kasi lalayo lang.
Oo, lalayo. Tatama yun sa net.
Yeah, knowing about the lesson
Oo,
kanina.
ang gagawin mo na lang, syempre kailangan mas mataas yung height mo, tapos mababa lang,
Yes.
maiksi yung range. So, medyo i-project mo siya, medyo malaking angle, sabi mo ng...
Yung unang-unang panahon, ginagamit nila yan. Kung bakit gumagalaw yun, para
Tapos tine-telescope na lang nila, sir.
Yes.
Noon. Ngayon kasi medyo digitized na yun.
Kahit yung ating mga Ma'am Jen, yung sa ating mga satellites, when we launch satellites, yung mga missiles, computed lahat yan, kung saan yung target niya, yun yung...
Oo.
May mga pumapalpak ata sa mga missiles na nilalaunch no minsan, ma'am.
wala sa
China, ganyan.
hindi pa tayo pumapalpak sa mga missiles
Hindi natin
kasi
kaya yun.
wala pa tayong
Kahit yung pag-launch ng satellite.
Zero trial pa, kaya wala pang ano.
Hindi sa ibang bansa kasi.
Oo. Tapos maliban doon yung nga kanina, ma'am, di ba? Nung sa pagdidilig,
Pagdidilig.
gamit ang hose, ayan.
Pati
Ano pa ba?
pag-ihi. ng mga boys.
Tesa ng palayuan kasi.
Ayos no?
O, yun.
Okay.
Tapos, ano pa ba?
Saan pa?
So, sa mga simpleng laro, o yung shatong, hindi na nila nadat na yun, ma'am.
Okay,
so,
siguro i-recognize lang natin, Ma'am Jen, yung sumagot kanina.
May sumagot kanina. Very good. Kasi kanina sagot nilang lahat constant. Sabi natin, yung value. So, may sumagot ng value. Si Christian Vino. Ang galing-galing naman. Talagang nakatutok siya. Sabi niya, ang acceleration ay 9.8 meter per second square. Okay. So, congratulations, Christian Vino. Pagpatuloy lang yan, anak. Lagi kang nakatutok. Yan, maraming salamat. So, yan, quick recap na tayo. So, ang ating projectile motion ay merong dalawang dimension, yung vertical and horizontal dimension. So, ano ang mga nakaka-apekto sa ating projectile motion? Una, yung initial velocity or the speed of projection, and another is the point or the angle of projection. Yun yung dalawang bagay na apekto sa kanila. So, meron din, yan. So, yun na ang ating RBI and live discussion for this week. Maraming salamat sa mga sumusuporta, lalong-lalo ng ating admin, headed by our officer in charge, Ma'am Ofelia Ralutin, head teacher 3, and our officer in charge. So, our science learning area, head teacher, Ma'am Annabel Rodriguez. Thank you, Ma'am. So, and sa lahat ng mga teachers at mga estudyante na laging nakatutok sa atin, maraming salamat. Sa ating mga technical specialist dito nakasama natin, Sir Dennis and Sir Mark, maraming salamat po. So, yan. Good day sa ating lahat and keep safe po, everyone. Goodbye.
Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day. Ito ang 106.3 Dan.